All right. So hello everyone. I'm giving this presentation is about the new AMD, our plans for a unified driver stack between our existing closed and open source drivers. So I guess the general idea is that we want to eventually get to a unified kernel driver and a fair amount of the user space support stack to be all open source. These have the obvious advantages of being upstream, being able to take advantages of that both drivers provide. It's pretty obvious. The new unified driver sort of builds on the existing Radeon base. It will be a new driver. We're not planning to open source the existing Catalyst stack, so this will be a brand new driver. But it's not going to be drastically different from Radeon, so it would still use TTM, DRM infrastructure, GBM, and we'll be using Glamour for our 2D acceleration. Internally too, we're going to be leveraging a lot of the Catalyst teams, so the code won't be necessarily ported over open source per se, but people from the Catalyst display teams and power management teams would now be working on open source. So it's going to kind of break down into sort of three stacks: an all open stack, non-pro, and what we call pro. The big difference between the non-pro and pro would be stuff like workstation features on workstation cards that are specific to cards, things like frame lock, gen lock, and stuff like that. So this is kind of what the all open stack would look like. Down at the bottom, we have our unified kernel driver, which we're calling AMD GPU. And then there's a user kernel interface library, and then the usual open source user mode drivers, our HSA stack, and then the non-pro. It's basically the same stack, but instead of having the Mesa user mode drivers, we have closed source ones. And MMD in this case stands for multimedia. And then for pro cards, and you'll notice that the green, the open source, may not be upstream. So we're going to try and get as much stuff upstream as possible, but there are some rather unsavory bits in our workstation code to support certain features that may not be acceptable upstream, but it will be open source, so customers that need those features will be able to use them. Obviously, we're going to try and, as much as possible, get that stuff integrated, but it is what it is. So then what is this stack going to look like? It's going to be, there's a common set of command submission and memory management IOCTLs that we're going to be standardizing on. Also the standard libdrm AMD GPU interface. As I mentioned, a possible Fire Pro add-on, common DDX, and the only real difference would be the user mode drivers. So the challenges we're running into, I guess just general hardware IP, registers, packets, etc. Getting more people working on open source, and then of course trying to provide more documentation. And there are a lot of various legal issues and stuff with open sourcing the Catalyst code due to third-party IP and things like that are involved in it. So from a perspective of IP review, the way it generally works now is when we decide to implement a certain feature on the GPU, like for instance video encoding, we have to go through the process of talking to the various hardware architects and stuff and legal teams to make sure that we only release the relevant bits and not anything specific that we can't release due to it not being our IP or to it being possibly exposing parts of our content protection scheme that we are not allowed to expose, things of that nature. So we've for the last few years we've sort of been working with the hardware teams to sort of change that process, where these sort of things are flagged earlier, and so by the time that hardware is ships, we have a better handle on what we can release and what we can't release, which cuts a lot down on our lead time for releasing support. And challenges, code. Probably, I mean, everyone, probably all of you, the guys that have worked, they've worked on open source in big corporate environments. There's a lot of internal teams that aren't familiar at all with the Linux processes, and a lot of education needs to take place. That's one of the things we're doing now, and just getting a lot of the internal teams to understand what those processes are, how they work, and then to be careful what they release and whether and what they do release meets certain guidelines and stuff for what's considered safe or approved. So we've been doing a lot of ramp up internally, and it's been challenging. Documentation. At this point, we've released 3D register reference guides, 3D programming guides, and shader ISA reference guides. As I said earlier, we've started to integrate more into the hardware design process. So I think we're going to be seeing progressively more and better documentation being released along with open source code. So that's another positive. And why are there still closed source components? That's a good question. I mean, basically, I think the goal is to eventually, I don't know that there'll be a need for closed source components, but today we have customers that need OpenGL4, certain OpenCL 2.0, 1.2 features that aren't available in open source. And even if we did put a ton of developers on Mesa, we wouldn't be there today. So for the time being, we still need these closed source drivers. And even if, for instance, we were to open source our Catalyst OpenGL driver, it's not like we could really integrate that into Mesa. So it would be, it's kind of a necessary evil at the moment. So where are we now, and what the future looks like for this driver? We did an initial implementation on this for Sea Islands, which is Bonaire, Hawaii, Kabini, Kaveri. So using that as our prototype and bring up driver, and we're also working on some new unreleased ASICs. And so all future support for all new ASICs will be on this driver as opposed to Radeon. So there will be no more new ASIC families on Radeon. Of course, we definitely want to see community feedback. Any features and things that the community feels that where they would like to have us support, or areas that need improvement, or places where we could better integrate with Upstream. That's pretty much it. Questions? Keith? Yes, but we the issue is like stuff like RHEL, where we need to support older distributions and stuff. With the new kernel somehow? Yeah. There's also some workstation features that they're not sure if they can get into, that they can make work without some stuff in the DDX.
Yeah. So as the RHEL maintainer, we're happy to add mode setting to older OSs, and we've done that, in fact. But there's definitely a lot of things that mode setting is clearly not prepared for. It doesn't have any concept of stereo. It doesn't have any concept of multi-sampling. Like, we could add all these things to mode setting plus glamour, and we probably should, but those are things that need to work on AMD cards tomorrow. So, you know, it's certainly a positive goal to have, but it's totally understandable that there would be no way you could do that tomorrow.
Yeah, I mean, ideally, we'd like to get to the point where we can just use, you know, glamour and mode setting in X, and you know, that would be that. But
yeah. And that will still be a thing that, you know, we'll probably test to make sure that before the DDX driver gets an update, that mode setting would load on that ASIC and run as
Yep.
well as would be expected. But clearly, for even some of the basic things for page flipping, things like that, or actually having XV overlays, or things that the Radeon driver can already do today, mode setting's not going to have. So we can get there, and I definitely think this is a good approach. I've been hoping to see something like this for all vendors for quite a number of years now, so I'm definitely excited about this.
anyone else?
So you said that you're trying to use the same kind of command stream IO still. Did you actually try to talk with the Catalyst team to do something kind of differently? Like, I know, for instance, if I were doing a new kernel driver and was doing a new IO still, I will be doing it differently than the one I did for Radeon.
Yeah, so I mean, if you've been tracking any of the recent changes we've made to Radeon, a lot of those are laying groundwork for this sort of thing. So it's definitely going to be a new command submission ioctl, probably some changes to the memory management ioctls. We're still sort of working out some of the details with the way Catalyst does things. I mean, they have a lot of requirements that just aren't going to fly out of the box on Linux. So it's been a lot of back and forth. You know, things like, you know, for OpenCL, pinning memory and stuff like that. You know, they basically just want to pin it forever, and that, you know, that's.
Yeah. I guess my point is also, like, for this kind of stuff, it's probably will be the most controversial part of the change we'll propose upstream. So I guess it will be nice if you can do it publicly as soon as possible.
Yeah.
Discussing the design, basically, like, because if you come to us with a design and there is something we really don't like about it, we're going to shut it down. And if we shut it down and you've been working on it for 6-8 months, it's not really nice for you or for anybody working on it.
Well, I mean, we're actually kind of going to be, I guess I could get into the schedule a little bit. We're going to be doing the initial release will be open source only, and we'll just be using it internally for prototyping. So Catalyst will continue to support, you know, some certain numbers of future generations of chips before Catalyst fully switches over to this stack, just to give us some time to get stuff integrated upstream and, you know, all those issues that you mentioned about whether things would be acceptable or not. And then, you know, once that stuff is upstream, there may be some of it, you know, there may be post-releases where we would support older chips that maybe also have Catalyst support on this model, but you know, there'll be like a generation or so where Catalyst will continue to be an option.
And putting my Red Hat on, so you say that VariPro gonna still add some kind of features that won't fly upstream. This kind of feature won't fly inside Rail either. So that means you will still have to build a special kernel if you want.
Yep.
A special kernel model for it.
Yeah, I mean, we're going to obviously try and avoid that if possible, but if necessary, then yeah, we'll have to do something like a DKMS package or something like that to support it. So, I mean, you know, it's going to be a challenge.
Yeah, it's like it's one of the things I was hoping to not have to bother about FGRX kernel driver, to not worry about it. So it would have really been nice if the VariPro codes can actually work out of the box with whatever we're going to ship with Rail.
Yeah.
Alex?
Yep.
Do you have any plans to add support for older families of chipsets to the new driver? And if so, how far do you think you can go?
Not at the moment.
Okay.
Yeah, just quick comment on the OpenCL. Like, why don't you just pin all the memory? Because we have the same discussion.
Yeah.
The current proposal we're throwing around is to do like in-kernel working sets that we track like per context or so, and then user space just tells the kernel, I want to run an OpenCL thing on that context. Please make sure everything is there. And for the usual case of everything is there, it's like a no-op.
Yeah.
And I guess that gives you about the same performance for the case where everything fits in memory while not totally killing the Linux kernel memory management.
Yeah, we'd thought about some similar things, and additionally maybe like a process to ask back for the memory, like let them pin it, and then if memory gets low, then ask them to free it. If not, then that we kill them.
Well, we didn't. Well, I mean, the kernel would like repin or re-swap
Right.
all the memory when such. I know obviously it's going to trash horribly if you ever run into the wall. But yeah, we essentially use the same shrinkage stuff that we currently have.
Okay.
I mean, compared to TTM, we allow like all of memory to be used for gem, which gives you interesting coding cases. When the shrinker kicks in. But yeah, that's kind of the rough plan we have. So the shrinker and everything still works. We just have like a dirty flag in the context. Some important buffer was evicted, so we need to walk the list again and pin them. Well, not pin them, but move them all back in where they should be.
Yeah. Yeah, it gets a little more challenging with HSA because we support user mode queues, in that case where the user can pin memory or can access memory directly. And for the general case, if the hardware, on all hardware we support HSA on, which is APUs at this point, the IOMMU can do demand paging, and the GPU will pause and wait for stuff to get paged in and out. So we don't really have to pin it, but for DGPUs and if you want to use like VRAM for a fast cache or something like that, then you've got to deal with pinning.
Yeah, maybe on the HSA thing. I mean, here we have that thing. It's not too not public, but that's essentially the point you raised, that there's no kernel with user space submission. That's essentially why we tell everyone that we want an ioctl, even if it's like the only thing the ioctl does is like writes to the doorbell.
Yep.
Just so that in the future we still have the option to do stupid things in case we ever need to.
Exactly.
Or something, yeah.
It sounded like one of the reasons that you weren't going to use Mesa in the last two stacks was that Mesa didn't have some of the features that you needed. Is that something that you're going to work towards adding? Are there other hurdles to using Mesa, or is it features?
It's largely the features, yeah. I mean, just the fact that we've invested in this other stack that has all the features we need today and is well optimized. And, like I said, obviously we're going in the future is going to be more focused on open source, but we need something to bridge that gap.
So is that you saying that you're going to try to add those features and
yes,
move
well,
to
we will
Mesa?
definitely be contributing to Mesa to fill in what,
So basically, if we could get a Mesa that was feature equivalent for all the OpenGL 4.x that we need, all the AMD extensions that currently exist on a particular workstation ASIC, then for the next one we might expect to see the open support for it. Maybe the two after that, because the one that you're developing would be still on Catalyst, and then the one after that you would say, okay, well, we know that we got everything at that point. We can maybe start by getting Mesa started there. But would that be a reasonable model to maybe hope for?
I can't guarantee anything, but yeah, I mean, I think that's generally the direction that we're trying to go.
All right, cool. So basically, it's up to us as the open source community to get Mesa to be, feature complete. Let's do that.
Is that it? Have you decided on the license of the kernel code?
It'll all be X11. MIT X11.
You need to be GPL too. Well, you can be X11 and GPL at the same time, but you need to be both at the same time. Well, I mean, it's a lawyer talk. Like,
Yeah,
lawyers
I don't know. I'd
involved,
have to
but-
double check with the lawyers, but it would be the same licensing that the current Radeon stuff has.
So it's dual license.
Okay,
Yeah.
yeah.
Hello, I had two questions. The first was, do you know the reason why this goes so open sourced? And the second one was, will it be Linux centric?
I mean, the reason why we've been going more open source is customers have been asking for it. So, I mean, that's, that one's pretty easy. As far as, I don't think there's any plans to open source our Windows driver, if that's what you're asking. So no, I don't think there's any plans for that. I mean, we do have an open source Windows CE driver, but it's based on our open source driver.
To be sure I understand correctly, the new AMD GPU driver is meant to continue the work of the Radeon driver. So the Radeon driver will support older hardware,
Right.
and the AMD GPU will support newer
Correct.
hardware. Okay.
Yep. So it'd just be a cutoff with the current, Radeon would support the current released hardware, and then all new hardware will end up on.
Will there be a time frame where a particular hardware will be supported by both?
I mean, there's like I said, there's some C Island spring up code that we have in there now. I don't know if we're going to keep that in when we upstream it or not. It's useful for playing with, but we obviously don't want two drivers for the same hardware, and we don't want to fix the bugs in two drivers per se. So, but yeah, there's no real plans for any overlap.
Thanks.
Right.
How do you plan to force them to switch to the new code base when you make the switch?
I mean, I guess we don't. There's no forcing. I mean, they can continue to add features and stuff to Radeon. I mean, we're going to continue to support Radeon on chips that it's currently supported on, but we're not going to be putting any resources into Radeon to add support for new ASICs.
I think that's it. Thank you very much.
Yeah.